Okay, last video of the series. Let's go ahead and do this. So one of the questions that I get a lot in this class is, Dr. Bruno, how do I know what statistic to pick to answer my research question? Well, in this video, we're going to give you all the insight you need to know to move that forward. So I've come up with a little bit of an algorithm that I like to think of. And really what it starts with is when people come to me and they say, what statistics should I use for my research question? I always start and I say, what's your research question? And the reason for that is because the research question is going to relate directly to the kind of statistical procedure that is appropriate to answer the question. So when somebody gives me a scenario or a research design that they came up with, I think about, okay, based off your research design, I know option A, option B, and option C of what's possible to analyze for that statistical data. And so I'm going to teach you how to do the exact same thing throughout the course this term. But really, when it comes down to it, there are really only about 4 basic research questions that we can ask in scientific research. And we'll cover each of these throughout the term in this course. The 2 primary considerations that we need to think about when we're trying to answer a research question with statistics is, what's your question and what kind of data do you have collected? So the 4 different types of questions that exist would be, what's your research question and what kind of data do you have? So the first of the 4 kinds of data that people typically bring to me is if the person wants to have a research question that asks the question about whether or not there is or is not a significant probability of something happening or not happening, right? So what is the probability that I will win the lottery versus that I will not win the lottery, right? What are my chances? And in healthcare, if somebody is given, let's say, a cancer diagnosis, we might want to know, what's the probability of living through this and being a cancer survivor 5, 10, 15 years down the line? So what's the probability of me being alive in 5 years? And what's the probability of me not being alive in 5 years in those types of situations? The second of the 4 kinds of research questions that we typically get is if somebody wants to know, is there a statistically significant difference between this group and that group? So is this group different from that group? Is this condition different than this condition? Is this treatment different from this treatment, right? So this versus that kind of research questions. And then the third question would say, is there a relationship between 2 or more variables? Does this variable relate with that variable? Is this correlated or related to that? And then the last of the 4 types of questions would be, if somebody isn't interested maybe in inferentially analyzing data from a sample to a population, but instead is more interested in, how do I describe or summarize this data that I've got? So if someone wants to describe their data and determine if there's a difference, they would need to use measurements of central tendency and dispersion in order to do that. So they're trying to just describe the data as it currently is. So once we understand the person's research question, and then we understand the kind of data and the kind of question that they want to answer, we then need to say, okay, is this data being collected with numerical quantitative values? If yes, then we move on and say, okay, great. We probably can perform parametric statistical tests in order to answer that question. And so in order to do this appropriately, we need to assume that the variable that we are testing, the outcome variable, is normally distributed, meets that basic assumption, and that the data for that normal distribution is typically continuous in nature. So it's either an interval or it's a ratio level of measurement in order to do that. You cannot perform these parametric statistics if the nature of the data is nominal or ordinal. So if you have a continuous question, but you have nominal or ordinal categorical variable, well, that doesn't work because your question is continuous in nature, but your data is collected in categorical nature. So that doesn't really fit. So you would have to use what's called a non-parametric statistical procedure in order to answer those kinds of questions, which we'll get into in the last lecture of the term. So with some non-parametric procedures, the beautiful thing about them, just as a quick overview, is that they are what's called distribution free, meaning they are not reliant on a normal distribution of data that's being collected, and they do not have the same stringent requirements as parametric tests do for having a normal bell-shaped curve, having a normal distribution, the data being symmetric and asymptotic and continuous. And so a lot of the basic assumptions that we talked about are only relevant to parametric statistical procedures. And if the data is mismatched, non-parametric procedures are nice because they sort of salvage and provide a backup for the parametric procedures, because they do not require the same stringent requirements when it comes to basic assumptions. And so you can use nominal or ordinal level of data that is most appropriate for interval and ratio data, but does not have to be in that way. So I hope this series was helpful. I know it was a long one, 10 little snippets to help you get through the first week of the term. Of course, if you have any questions, bring any questions to class. You're welcome to come to my office hours. We'll see you all in class, and I'm looking forward to rolling up our sleeves and working through assignment 1. We'll see you there.